Okay, question what number is this? Number 1 essay lah. Question 16. This one is not essay. Question 16 is subjective question. So a circular deck with a radius of 10 meter is rotating above the water's surface to make one complete cycle in 1 minute as shown in the diagram below. So a man X with a mass of 70 kilogram at platform A, so here is the platform, jumps on the deck to reach platform B. So calculate the angular velocity of the deck. So you are given the radius period. So because this is one complete cycle for 1 minute. So that's mean period is 1 minute, convert to seconds is 60 seconds. Okay. And then the mass of the man, 70 kilogram. So we are going to determine the angular velocity, omega. Okay, the solution is, okay, period 60 convert to 60 second. And to calculate the angular velocity, omega, we use 2 pi f. And f is 1 per t, so becomes 2 pi per t. So we substitute 60 seconds into the equation. The angular velocity is 0.1047 radian per second. Okay, this one very easy. You can easily get 2 marks here. So this 2 marks is for the equation, okay, and for the answer. Okay, either equation for the or the substitution. Okay, both. So 2 marks. Okay, next, okay, this is angular velocity. So we keep this for the next question B. So question B, calculate the centripetal force experienced by X. Okay, centripetal force is F. F, centripetal force. So because of we are given, we calculated just now omega, angular velocity, and R is given. So from the 3 equation, we use which one? Mr omega squared. We choose the second equation for centripetal force because V is not given. So F equals to Mr omega squared. So we substitute 70 into the question, into the equation. R 10 meter, okay, already in SI unit, and angular velocity 0.1047. So before you come to the final answer, make sure you substitute the values with significant figures one step larger, one step larger, usually larger than 3 lah. Okay, so because given R 3 significant figures, so you must substitute the values here larger than 3 significant figures. So that's why you can see here why it is written 4 significant figures. So that your answer here is in the range of examiner answer. Okay, the marking scheme answer. Okay, so this is the final answer for centripetal force, 7.67 Newton. So you can write here in 3 significant figures because the given here 3 significant figures, even though M is only 1 significant figures, here 1 or 2. So you may write 3 or 2 actually, the number of significant figures. Okay. Next, we continue with question C. Okay, question C, angular velocity, mass and R. Okay, angular velocity calculated already. So we are going to calculate the tangential velocity for X at the edge of the deck. So here at the edge of the deck. So once it jump, so the velocity jump onto the deck. So what is the velocity for the man? The man X-man. Okay, so we tangential velocity because angular velocity calculated already, R also given, so we can use equation V equals to R omega. Okay, no need to use again F equals to mv omega Also can actually MV omega. Okay, so we use this one. V equals to R omega. So substitute the omega here and R here. So we get 1.05 meter per second per second. So the answer is in 3 significant figures. Okay, so that is a radius. Then the D question, state the force enable X to remain stationary on the deck. So for X to remain stationary on the deck, the force is a friction lah, surely friction lah. If not, the man will slip and slip to the tangent with the velocity v tangent to the circle motion here. Okay, so any question for question 1?
So teacher, that means that the frictional force is more than the centripetal force, right?
Is equals to the frictional force. So the frictional force provided the centripetal force. In this case, okay, the centripetal force is provided by the frictional force. No other force involved. Mg not involved because Mg is perpendicular to the centripetal force. Okay?
Oh, okay.
Okay. Okay, any more problem? Okay, so if no problem, we go to the next question. Question 1 for STPM 2017-18. Okay, so question 19. This is essay question. 18, 19 and 20 is the essay question. So 1A, okay, one question equals to 15 marks, okay, 15 marks. So here is the sub marks, 3, 2, 4, 3 and 3, so altogether 15 marks. So question A, derive a relationship between linear velocity V, angular velocity omega for an object moving in a circle of radius R. This is the derivation question. Okay. So first step, because we want V, omega and R, so we draw the V, what is this? V, R and omega, okay. So V, R and omega. So let's say L equals to length and the radius of the object moving in a circle is R and theta is angular displacement, okay, theta. So the L equals to R theta means we use this diagram for reference for the circular motion. So let's say it moves with length L here. L actually the arc length, the arc length. S, the arc length. So we use formula S equals to R theta. So S, the displacement is L. Okay, it's not R, it's the L, the length travel here, P to Q. Example in this diagram lah, P to Q. Okay, then we divide both sides by T. Okay, we still don't change the equation because when we cancel T, we still get L equals to R theta. So it's okay to divide it by T both sides. Okay, then L per T is velocity. Okay, then theta per T is angular velocity. Okay, angular velocity is equals to angular displacement divided by time. So we substitute into here, we get V equals to R omega. So this is the answer lah. Okay, the question said derive relationship between V, omega and R. So all here already, V, R, omega. Okay, that's question 1A. Okay, understand? Any question on 1A? No, Okay, so for 1B. A car moves with constant speed along a horizontal curve of radius 60 meter, 60.0 meter. The coefficient of static friction between the road and the tires is 0.72. So draw a label diagram to show the forces acting on the car as it negotiates the curve. Okay, so that's mean this in horizontal curve. So that's mean this is a circular motion. Okay, Okay, let's say this is the car and the car move in a circular motion horizontally. Okay, so where the center is here. Okay, center. So I didn't draw the horizontal circle, only the center of the circle here. So you determine all the forces that act on the car. So the forces are friction, okay, friction. This is called lateral friction actually towards the center. Okay, then we have normal reaction R, and then the weight of the car, okay, mg acted downward. Okay, then this is all the forces that act on the car. So draw a label diagram to show the forces acting on the car. Okay, next, done already for B1. Okay, next, determine the maximum speed for the car without skidding. So the car move in a horizontal circular motion. So where is the direction of the centripetal force? So the direction of centripetal force must be towards the center. So that means we need to get to determine the forces that provide the centripetal force, which is along the centripetal force. Okay. So for B2 question, okay, the centripetal, the force that along the centripetal force, act along the centripetal force is only friction. Okay, normal reaction is vertically, so doesn't have effect, doesn't provide the centripetal force. Weight also perpendicular, also no horizontal component to provide the centripetal force. So only left friction. So that's why we equate to friction, or another word, friction provide the centripetal force. Remember that centripetal force is the resultant force. So from this all, the resultant force only from friction. So friction is equals to mu r, and from here r is equals to mg, because the car doesn't fly, and then the ground here doesn't collapse. So they are equal, r equals to mg, and the car maintain moving in a horizontal circular motion, okay, horizontally. So r equals to mg. So mu r here we substitute mg into r, so we get this equation. Then we can cancel the m, so we get v squared equals to mu rg. Okay, so we substitute the values. Mu given 0.72, r radius is 60.0 meter, and g value is 9.81. The answer is 20.6 meter per second. Okay, that's the answer. Maximum speed for the car without skidding. Okay, any problem with this question? All okay?
Teacher,
Yeah.
just asking, in the exam, right, if I don't follow the correct significant figure, maybe I give one extra, is that still okay?
Pardon? What extra?
Like my answer is 20.59, right? So I didn't round off to three significant figures. Is that still considered okay?
How to get final answer? Only allowed. Okay, you refer to the data given or the information given. So you look at the largest, the smallest significant figure. So the smallest significant figure here is 2. Okay, so the largest is 3. Okay, 3. So you are allowed to answer your given your answer one step higher. So if you answer in 4 significant features, still okay lah. Still okay. But
Oh,
advisable, you refer to the information given here. This is 2, right? This is 3. So better write 3 or 2 only lah, because the 4 significant features you answered, right? I'm still not sure lah. Even though I was given info that one step higher can still be accepted. Understand or not? Okay, always refer to the information given.
okay, okay.
Understand? Okay, so actually for the experience with before this, Okay, usually three significant figures lah. Answer significant figures for answer. Okay, the number of significant figures for final answer. To be safe is you round it off to 3. Okay. So we go to the next question. C. Okay, C. A mass which initially at rest slides down from the highest point P, highest point P of a smooth sphere. So smooth, what does this mean? No frictional force involved. Radius R, okay, the circular motion is radius R, shown in the diagram. So when the mass reaches at Q, the angular displacement is theta. So this is all given angular displacement theta. V velocity, R is the radius. So we are going to determine this velocity in terms of R. R is given here, R, G and theta, okay? Theta is given. Okay, so we use, in this case, we use principle of conservation of energy, okay? Principle of conservation of energy, where from total of kinetic energy remain constant all the time, and we rearrange kinetic energy one side and potential energy one side, and finally we get this one. Okay, we get gain in kinetic energy equals to loss in potential energy. Or another saying is change in kinetic energy or change in potential energy. It's the same lah. Okay, now kinetic energy. So the kinetic energy changes from initially U is 0. So therefore, the mass initially at rest slide. So that means kinetic energy initially is 0 because U is 0. And at the point here, Q, kinetic energy is half mv squared. Use the V given here. So that means the change in kinetic energy is half mv squared minus 0. So half mv squared. Okay, this is gain in kinetic energy. Okay, right side is the loss in potential energy. So the potential energy, so you refer the point center here. Okay, here to P0 to P is R. So from 0 to the point Q here, the level drawn here, okay, dotted line, red dotted line. So you use trigonometric ratio to determine the distance here. So that means you use cosine, cosine theta. Okay, cosine theta adjacent per hypotenuse. So hypotenuse here, this is hypotenuse is equals to radius also. So cross multiply, you get R cos theta. So the height Q, okay, for the potential energy is R cos theta. So that means the changes or the changes in potential energy or the loss in potential energy will be, okay, at the maximum height is mgr, okay, at this point mgr, and then at this point or level, at this level is mgr cos theta. So you substitute the height from center to point Q is r cos theta into mgh. General formula is mgh, so the height is r cos theta. So the change in potential energy, so you minus lah, which one is larger? MGR is larger, right? So MGR minus MGR cos theta. So this is loss in potential energy. Okay, so we get this expression from principle of conservation of energy. Okay, next we can cancel out M. So we get V squared equals to 2G bracket R minus R cos theta. Okay, cross multiply 2. Okay, then the square root, V squared equals to, okay, here we factor out R, right? Just to simplify the expression here lah. Okay, then square root. So this is velocity in terms of, okay, check the question in terms of R, G and theta. So all is in R, G and theta already. Okay, even though not mentioned here G, you can still write G because G is the general symbol for acceleration due to gravity. Okay, so C1 done. Any question on C1? Okay, good. Silent means understood, right? So we go to question C2. Okay, question C2. Calculate the angular displacement theta when the mass flies from the surface of the sphere. Okay, from the surface of the sphere. So the angular displacement theta. So that's mean angular displacement means we use circular motion. So centripetal force. We need to use the centripetal force provided by the circular motion here. Okay, so the centripetal force is given by mg cos theta minus r. Okay, r is upward force. Okay, so I didn't draw here. Pen. So upward force. Okay, this one is r. Oh. Okay. Then the weight of the object. I didn't have my pen here, so okay, mgr equals to mg is towards the okay. So mg is downward. Okay, mg is downward. Mg is downward. Then r is upward. So therefore, r is negative. So mg cos theta minus r. Okay, at the top peak P, but at the Q, we resolve the component of weight becomes mg cos theta. So that's why at point Q is mg cos theta minus r. Okay, okay or not? Can Remember at Q, mg is downward. So we resolve the component along the OQ towards the center of O. So along the OQ here will be mg cos theta. Okay, then equate to the centripetal force. This is centripetal force, mv squared per r. Okay, next we cancel the m both side. Okay, for the question asked mass fly, so that's mean its maximum speed reached by the marble. Is it the no? It's a mass. So the maximum speed reached by the mass where this r equals to 0. So it cannot hold on the mass to maintain or to remain a circular motion anymore. So that's mean the minimum r is zero. Okay, so we'll give you the maximum speed. So we substitute this value r0 into the equation. So mv squared per r equals to mg cos theta. Okay, same as we've discussed in the lesson before. For the washing machine, the r also 0 for the what you call that clothes, not to fall down or drop down from the wall of the washing machine. So same case goes here. So R0.
Teacher, can you explain that last part about R? I got a bit confused.
R0.
Yeah, yep.
So if R0, so no, R is outward, right? So if R0, so no more force to balance the what you call this mg cos theta. So that's why the mass are not stable anymore. So it will flies off. Okay, flies off from the surface. So that is why to remain centripetal force for the maximum speed is r equals to 0. Okay, if not, if r larger, if r is larger, so it's still manage to maintain, to give the for the object, for the mass to keep in a circular motion. Okay, to keep moving in a circular motion. So for maximum speed, r must be 0. Okay, same also as you whirl around a glass of water, or the basin with water, whirl down in Actually, not the circular motion here is horizontal. No, it's a vertical. Okay, it's a vertical. So for the, if you whirl the water bucket, let's say you put in a bucket, so the water does not drop is because of the reaction force. Must if equals to manage to keep one round, so R also equals to 0. So got many cases or situation use R equals to 0. Okay, so continue with from here. So R0, the equation becomes like this. So now we cancel the M both side. Okay, cross multiply, we get V squared equals to GR cos theta. Okay, from this equation, okay, to find what the question asks. Okay, so from the previous one, okay, we get V squared equals to 2GR bracket 1 minus cos theta. And then this is a second equation. So the C1 becomes first equation, C2 becomes second equation. So we can use simultaneous equation to simplify. This becomes to find V, to determine the V. So we equate them both. Okay, we equate them both because the V is the same V. From the principle of conservation of energy, we derive for V. So the same V we use. So that means both are equal. So we equate them and then cancel the G. So cos theta becomes 2 minus 2 cos theta. Okay, expand the bracket. And 3 cos theta equals to 2. Okay, bring to the left side become 1 plus 2, 3 cos theta. So cos theta equals 3 per 2. So lastly, we get theta equals to 48.2 degrees. So this is the angular displacement for the when the mass start to flies off from the surface of the sphere. Okay.
Teacher, not 2/3, is it?
Yes, 2/3. So do you get the same answer not? But the method is correct. The method is correct. So you try to check the answer for theta if this one change to 2 per 3. Okay, so typing error here. Okay, don't make careless mistake like this. Like here given here is a careless mistake. Okay, any more problem? No, Okay, so no. Then we go to question, next question 2. This is year 2019-2020. Last year, 2019, 2020. Okay, last batch lah, your seniors batch. Okay, so we read the question first, 2A1. A body moves with uniform speed in a circular path. Explain why the body experiences acceleration. Okay, so how to solve this? Why the body experience acceleration? So acceleration, if in circular path, acceleration is towards the center, towards the center. So first step, first what you call this point, first point, direction of the motion changes. Okay, direction of the motion changes. So what is A? Actually, A is a change in velocity per time. So time is a scalar. So change in velocity. So the velocity change because of the direction. Okay, of the velocity change. So velocity changes, motion change, velocity change. Every time on the point, the point on the circular motion, every time it is changes. So therefore, acceleration is also change because again, I repeat, acceleration is the rate of change of velocity or V minus U per T. If in the form of equation V minus U per T, so in statement, we say rate of change of velocity. So the V change, V minus U change, so that means acceleration also change. So that's why we say that the body experience acceleration, even though the speed constant, because the velocity changes. Okay, next we go to 2. And another one, 2A here got 3 marks. Be careful, 3 marks. So must have these 3 points. Okay, 3 marks, refer to the marks here, 3 marks. So must have these 3 points. Then you get a complete answer for suitable for the 3 marks. Okay, next we go to A2 question. We are going to derive an expression for the acceleration in terms of speed v, radius r of the circle. Okay. Okay. So derive expression. So derive expression, we start with the circle. Okay. So from initial position to final. So initial position, actually this one must drawn here lah. Okay. So the typing error also lah. Should be drawn here. So V1 is tangent to the point and V2 also tangent to the new point here. So the object move from here to here with angular displacement theta. Next we draw, before that you mention at the point here initial time t 0, so we call the velocity as V1, and at as it move with time t, okay, generally just write t, so the velocity becomes V2, changes it changes direction, but with the same value v. So angular displacement, let's say theta, and this theta is a very small angle. Okay, for derivation we use a very small angular displacement. Okay, theta is angular displacement. And then we know that change in velocity is V2 minus V1. So we draw a vector diagram to represent this change in velocity. Okay, so the vector diagram, V2 is this way. So minus V1, that means the V1 we need to change direction to here. So you follow the angle here using vector diagram. So the resultant is equals to the change in velocity, because V2 minus V1. Okay, from sum of vector, this is V2 minus V1. So we get delta V. V2 minus V1 is delta V or change in velocity. So the direction is upward. For a small angle, you will find that delta V is towards the center. Okay, here not look like towards the center because theta we draw bigger size. If we draw smaller size, you will find that they are directed. It is directed towards the center. Okay, then for angle, for angular displacement small, so the delta V is equals to this one not yet. Okay, so V2 is equals to V1. They are equals in magnitude. So that is why delta V is directed towards the center. Okay, you can refer to my lesson notes, PowerPoint notes. I've given this already. Okay, this lesson before. Okay, then magnitude of vector delta V, okay, using maths equation, remember S equals to R theta, length of a arc, length of a arc. So delta V actually here is a arc, but for small distance can say as a straight line, so equals to V theta. So from S equals to R theta, the R is actually the V, the V for this diagram lah. Okay, okay, these two is a similar triangle actually. Okay, similar triangle. So this is V, this is V1. So this is theta, right? So this V here also V. So it's a similar triangle. So the length here, up here is given by delta V, the changes in V. So you can use V theta. Okay, from this equation, you divide by T both sides. Okay, so if you divide by T both sides, you still don't change the equation here. You still get delta V equals to V theta. Okay, I repeat, delta V is change in velocity. So change in velocity per time is acceleration. Okay, whereas angular displacement theta per t is angular velocity. So we substitute the value of acceleration equals to v omega. Okay. So the acceleration here use symbol alpha, but it doesn't matter. A or alpha can be used as a symbol for rate of change of velocity. Okay, then from the previous derivation, V equals to R omega. Okay, you can substitute into this equation, V equals to R omega, and simplify this equation becomes acceleration equals to R omega squared. Then check the question. The question asks to write the expression in terms of V and R. So in terms of V is this one. This is 1 mark. This is in terms of R. Okay, 1 mark. So 1 mark, 1 mark. That means the rest 3 is for the equation. All this. So 5 marks. Okay, you can rewrite direction of delta V towards the center. Okay, mentioned already just now, right? But haven't written yet. So we write direction of delta V is towards the center. So therefore acceleration is towards the center. Okay, and the centripetal force follow the direction of acceleration also towards the center of the circular motion. Okay, that's all for 2A2. Okay, any question on 2A2? Understand? Okay, silence means understand. Okay, we go to 2B. 2B, a steel ball of mass 50 gram moves with a constant speed in a horizontal circle of radius 2 meter. So the period of motion is 1.6 second. Calculate the centripetal force which acts on the mass. Okay, so question B. So given 50 gram and then mass, radius r and period t. So we need to determine the angular velocity from the period. So angular velocity 2 pi f, then 2 pi per t. So we get angular velocity. Then we have omega, m and r. So we use centripetal force equals to mr omega squared. Okay, then we substitute all the values given. Okay, so the answer is 1.54. So if you realize here, periods given in 2 significant figures, so the answer is 1 significant larger. Okay, so 3.93. So then this value substitute into here. Okay, then the final answer, this is 2 significant figure, this is 3 significant figures. So you are allowed to write in 3 significant figures. Don't write 4 lah, usually 3 significant figures. Okay, so any problems in question 2B? So if no problem, we go to question C. An object is tied to a string of length 45 cm and whirled around in a vertical circle. Okay, so this is vertical circle, not horizontal, with the constant speed. So determine the minimum speed for the object so that it moves around the vertical circle. Okay. So the C question, at the peak here we have forces, weight, okay. Force act on the object is weight, and then this is string, right? String, so we have tension in the string also. Okay, the tension act towards the center every time during the circular motion, directed always towards the center. But mg at all point is directed downward, but T no, because it is related to the string, so it's towards the center of the circle. Okay, when the object is in circular motion, this is vertical circle. Okay, now from these two forces, because they are in the line joining the object and the center, or another word, T and mg is along the centripetal force. So T and mg provide the centripetal force. Okay, from the F equals to, we use mv squared per r, we use mv squared per r because we are going to determine V. Angular velocity not given, so that's why the suitable centripetal force is mv squared per r. So mv squared per r is centripetal force is provided by the mg plus t. Okay, so the equation supposed to be mg plus t, but the questions wants only the minimum speed. So for the minimum speed, the t is equals to 0. Same case as just now, involve r, right? R and mg. R and what? Mg just now, the previous question, in the previous slide. So R is 0. But in this case, not R, R not involved here, T involved. So for minimum speed, it managed to make a complete circle here. So minimum T is 0. Okay, so the equation becomes mg only. So understand or not? Okay, now we cancel the m. So the equation becomes v squared per r larger and equals to g. Okay, next. We cross multiply, we get v squared larger and equals to gr. Okay, then v larger and equals to square root of gr. Okay, so for the minimum speed means equals here, we choose the equals. To make many complete rotation, sorry for that. For the object to move in in complete circular motion, the minimum speed is given by v equals to square root of gr. So we substitute the values given, 45 cm. Don't forget to convert to meter. So that's why here is 0.45. So the answer is 2.10 meter per second. Okay, so answered for question C.